So GTQ 2024 that is Gate Through Questions 2024 में आपका स्वागत है and now we will be going to discuss the thermodynamics part और thermodynamics को what we will do is we will try to cover the thermodynamics part through the questions and we will cover some important questions for Gate 2024. So this is going to be a very important session. Before going to exam you must go through these questions, right? So let us start solving questions one by one and my advice is that if you are seeing this video, attempt these questions yourself and then you can take the help of the solution which I do. That will actually also help you know कि आपकी कितनी तैयारी है गेट एग्जाम से पहले, ठीक है? तो let us begin the question solving. Now the question number 1. For a closed system undergoing a cyclic irreversible process, a closed system है, it is undergoing a cyclic irreversible process, right? Cyclic integral del q ds is cyclic integral of ds is. So देखो, the question is talking about the cyclic integral of ds. Now entropy is a property. Now if entropy is a property and your system is undergoing a cycle, that means the initial condition from where you started is the same as the final condition, then no property of the system will change. The change in any property during the cycle will be 0. So cyclic integral of ds will be 0. Process reversible hai, irreversible hai, it doesn't matter. It doesn't actually matter whether the process is reversible or irreversible. Why? Now some people will think, sir, the process is irreversible, so I mean the entropy generation will take place. Yes, the entropy generation will take place because the process is irreversible. But if you have to bring back the system to the same initial condition, अगर आपको system को initial जैसी condition है उसी condition में वापस लाना है, तो whatever the entropy has been generated within the system should be sent out. वो system से बाहर जानी चाहिए ताकि system अपनी initial state में वापस आ सके, so that the system returns back to its initial condition and the change in any property of the system will be 0. क्योंकि कोई भी property system की condition dependent होती है. तो ऐसा नहीं कि entropy generate नहीं होगी, entropy generate होगी अगर process irreversible है, but वो generated entropy फिर बाहर भी जाएगी when you return back to the initial condition. Fine. So our answer for this question is C. So this was an MCQ multiple choice question. इसमें एक option सही होगा and that option is C. Fine. Now let us move forward to the next question. So question number 2 which we are solving is NAT, that is numerical answer type problem. Let us go through this question. I have told you that I'll give you the time for attempting also. I mean not in the video itself, but I'll just move aside and you can see the question and you can pause the video and attempt. Now I will be solving this problem. See here, air flows through a pipe at 2 kg per second. So let me just represent a pipe here. I'll represent a pipe through which the air will flow. This is the pipe through which the air will flow. And the flow is at 2 kg per second, right? So flow will happen at 2 kg per second. Suppose this is section 1 of the pipe and this is the section 2 of the pipe. This is section 1 and this is section 2. Fine. So we are solving this problem. Yeah. Now the 2 kg per second is the mass flow rate that is taking place. So the mass that is flowing will be 2 kg per second. The same mass will go out of the pipe also. The temperature drops from 800 degrees Celsius to 790 degrees Celsius. So the temperature here at the inlet is 800 degrees Celsius. So 800 plus 273, that is 1073 Kelvin, and the final temperature T2. The final temperature T2 will be 10 degree less than this, that is 1063 Kelvin. So why the temperature drops? क्यों drop होता है temperature? The temperature drops from 800 to 790 between two sections of the pipe due to heat loss to ambient. तो ambient को heat loss होता है. That means through the pipe there will be a heat loss from the pipe to the ambient. So this heat loss, let us say, is taking place at a rate of q dot. ये q dot rate से heat इसमें loss हो रहा है, ठीक है. Now the heat loss is taking place, ambient temperature is given to be 27 degrees Celsius. तो जो ambient का temperature T naught, this is 27, that is 300 Kelvin. This is 300 Kelvin, right? Neglecting any pressure loss, pressure same रहेगा air का. The rate of irreversibility is dash kilowatt. So we have to represent our answer in kilowatt. Cp is given to be 1 kilojoule per kilogram Kelvin, right? Now, if we see the irreversibility, so for finding out the irreversibility, what we have to find out? We have to find out the total entropy generation that is taking place, or the entropy change of the universe. So, for the entropy change of the universe, there will be entropy change of the air that is flowing through the pipe, and there will be the entropy change of the surrounding, right? So there are two things, the air that is flowing through the pipe and the surroundings. So what I can do is, I can start calculating from here. So I'll say the rate of change of entropy of the universe will be equal to the rate of change of entropy of the air that is flowing through the pipe plus the rate of change of entropy of the surrounding. Now, for calculating the entropy change of the air, we have the initial and final temperature of the air. Pressure change is neglected, that is, pressure is almost the same. So what we can write is the entropy change of the air, delta S air will be equal to the mass of the air into entropy change per unit mass. So what is the entropy change per unit mass? Cp ln T2 by T1 minus R ln P2 by P1. Now why I am using this formula? ये formula क्यों use कर रहा हूं मैं? ये formula मैं इसलिए use कर रहा हूं क्योंकि pressure same रहेगा, तो pressure का drop नहीं है, तो P1 P2 same है, this will be 0, ये 0 हो जाएगा, ठीक है, ये 0 होगा. तो ये 0 होगा, तो what we have already have the mass flow rate, हमारे पास mass flow rate है, we already have the mass flow rate here. तो mass flow rate पता है, तो we can find out delta S dot air. So delta S dot air will be equal to mass flow rate is 2 kg per second, ठीक है, और into Cp कितना है? Cp is 1 log of final temperature we know is 1063 and initial temperature कितना है? Initial temperature is 1073, ठीक है, इनिशियल टेम्परेचर है 1073. तो यहां से एंट्रोपी चेंज ऑफ द एयर पर यूनिट टाइम आ जाएगा, तो 1063 डिवाइडेड बाय 1073 एंड लॉग ऑफ द आंसर इनटू 2. सो डेल्टा एस डॉट एयर की जो वैल्यू आ रही है माइनस 0.018726 है, तो आई एम राइटिंग 73. अब ये जो यूनिट आएगी ना, यूनिट विल बी इन एंट्रोपी की यूनिट होती है दी किलोजूल पर केल्विन, राइट, बट पर सेकंड भी है क्योंकि वी आर राइटिंग द रेट, तो किलोवाट पर केल्विन, तो यूनिट विल बी किलोवाट पर केल्विन, इट विल बी किलोवाट पर केल्विन. एंड हाउ टू फाइंड आउट द एंट्रोपी चेंज ऑफ द सराउंडिंग? सो सराउंडिंग की एंट्रोपी चेंज के लिए व्हाट वी हैव टू डू, वी हैव टू फाइंड आउट हाउ मच हीट इज रिजेक्टेड टू दी सराउंडिंग. हमें सराउंडिंग को हीट रिजेक्शन निकालना होगा, ठीक है. सो एंट्रोपी चेंज ऑफ द एयर हमने निकाल लिया, नेगेटिव इसलिए है, आई विल ऑल्सो जस्ट चेक माई कैलकुलेशन वंस बिकॉज आई हैव ऑलरेडी कैलकुलेटेड इट, मैंने कैलकुलेट कर रखा है ऑलरेडी. नेगेटिव इसलिए है बिकॉज इट इज लूजिंग हीट लूज कर रही है एयर, है ना, इसीलिए नेगेटिव है, बट दैट हीट विल गो टू द सराउंडिंग. तो कितनी हीट जा रही, दैट इज इंपॉर्टेंट फॉर अस टू कैलकुलेट. So for that what we will do is we will write the energy inlet in this pipe should be equal to energy exit, energy conservation, है ना. तो for pipe के लिए energy inlet rate should be equal to energy exit rate. तो energy inlet किसके थ्रू हो रही है? We have the mass entering, so m dot into h1 is the enthalpy per unit mass. कोई और एनर्जी, काइनेटिक एनर्जी, पोटेंशियल एनर्जी हैज नॉट बीन गिवन, सो वी विल राइट m dot is the mass into H1 is equals to how much is the mass exit, m dot is itself conservation of mass into H2 plus q dot. So we can find out easily q dot, value of q dot. q dot की value मिल जाएगी, we can find out the value of q dot. So q dot will be equal to m dot into H1 minus H2 और H1 minus H2 को क्या लिख सकते हैं, एयर है Cp dt, right? So m dot is 2 into Cp is 1 into dt T1 minus T2. So drop in temperature from 800 डिग्री सेल्सियस तो 1073, अगर केल्विन में देखें तो माइनस 1063 दिस. सो Q डॉट की वैल्यू आ जाएगी, इट विल बी 20 क्योंकि ये तो 10 आएगा एंड इंटू 2. फाइन. So we will get the value of Q dot from here. We will get the value of Q dot from here, right? So we can write Q dot equal to 20 kilowatt. Q dot 20 kilowatt मिल गया. अब Q dot 20 kilowatt है. This 20 kilowatt will be added to the surrounding at the temperature of the surrounding, which is 300 Kelvin. So entropy change of the surrounding delta S surrounding dot means per unit time. So this will be equal to Q dot upon T naught. Now we will decide the sign. Now see what some people say. कुछ लोग ये कहते हैं सर ये हीट अगर एयर से रिजेक्ट हो रही है तो प्लस साइन क्यों आ रहा है. देखो मैंने ये जो इक्वेशन लिखी है ना, द इक्वेशन आई हैव रिटन एंट्री एनर्जी इक्वल टू एग्जिट एनर्जी. साइन कन्वेंशन हमेशा तब आता है जब आपने कुछ मान लिया एंट्री है और वो एक्चुअली में एग्जिट हो, या कुछ एग्जिट हो आपने मान लिया वो एंट्री हो. तो जो एंट्री वाली एनर्जीज है उसको एंट्री वाली साइड रखा, जो एग्जिट वाली है उसको एग्जिट वाली साइड रखा. तो हीट को मैंने एग्जिट वाली साइड रखा ना, आप देखो तो इसीलिए वैल्यू आ गई. और डायरेक्शन मुझे खुद ही पता है कि दिस इज द हीट विच इज एग्जिटिंग द पाइप, है ना. तो अगर मैंने एग्जिट माना, मैंने एग्जिट की तरफ रखा और माइनस आ जाता तो फिर इसका मतलब था ना कि ये एंट्री है एक्चुअली में, मैंने एग्जिट मान लिया, गलत मान लिया. जो स्टैंडर्ड फॉर्मूले होते हैं ना थर्मोडायनेमिक्स के, वो जो स्टैंडर्ड एक्सप्रेशंस है थर्मोडायनेमिक्स के, दे विल एज्यूम द हीट ऑन द एंट्री साइड. जैसे आप एसएफई लिखोगे तो एसएफई में क्यू को आप एंट्री की तरफ रखते. अब इसमें मुझे दिख रहा है कि इट विल बी एग्जिट बिकॉज द टेंपरेचर ऑफ द एयर इज रिड्यूसिंग, सो हीट रिजेक्शन मस्ट हैव टेकन प्लेस. आप अगर एंट्री की तरफ रखते तो फिर माइनस आपको मिलता, तो फिर आप कहते क्योंकि मैंने एंट्री की तरफ रखा माइनस है तो माइनस का मतलब एग्जिट है. अब देखो सराउंडिंग में क्या है, द हीट विच इज गोइंग आउट ऑफ द पाइप विल बी एब्सॉर्ब्ड बाय द सराउंडिंग, है ना. तो सराउंडिंग में तो दैट एनर्जी इज एंटरिंग ना, वो एनर्जी आ रही है सराउंडिंग के अंदर, तो वो एनर्जी आ रही है तो प्लस 20 बिकॉज सराउंडिंग इज रिसीविंग दैट एनर्जी अपॉन 300 Kelvin is the temperature of the surrounding. So 20 divided by 300, it will be plus 0.066. ये कितनी digits हैं, 1 2 3 4 5. So there are 5 digits. So this and 7 round off. I'll do the round off then. So kilowatt per Kelvin. So what is the entropy चेंज ऑफ द यूनिवर्स देन. तो यूनिवर्स का एंट्रोपी चेंज क्या आ जाएगा फिर, एंट्रोपी चेंज ऑफ द यूनिवर्स इज द सम ऑफ बोथ ऑफ देम. वी हैव ऑलरेडी रिटन. सो इंडिविजुअली वी हैव फाउंड आउट. नाउ माइनस 0.01873 प्लस 0.0667. So it will come out to be 0.04794 किलोवाट पर केल्विन. ठीक है. तो इररिवर्सिबिलिटी क्या होती है, इररिवर्सिबिलिटी वॉट एवर इज द टोटल इररिवर्सिबिलिटी, इट विल बी इक्वल टू टी नॉट इनटू द एंट्रोपी चेंज ऑफ द यूनिवर्स कह सकते हैं, या एंट्रोपी जनरेशन. जो भी टोटल एंट्रोपी जनरेशन होता है ना, दैट विल इंक्रीज द एंट्रोपी ऑफ द यूनिवर्स. ये आ जाएगा. तो इंटू टी नॉट इंटू 300 अगर मैं करूं तो व्हाट आई विल गेट इज 14.382. तो जो आंसर आएगा वो आएगा 14.382. आंसर विल बी 14.382 किलोवाट. सो 14.382 किलोवाट का मतलब ये है कि यहाँ पे जो डेटा फिल होगा राउंड ऑफ टू 2 डेसिमल प्लेसेस, तो इसको राउंड ऑफ भी करेंगे तो क्या आएगा 14.38. सो वी विल हैव द आंसर 14.38 kilowatt. Fine. Please take this. I'll just move aside and then we'll move forward to the next question. So let us move forward to the next question. Now क्वेश्चन नंबर 3. क्वेश्चन नंबर 3 एक MSQ है, मल्टीपल सेलेक्ट क्वेश्चन. इसका मतलब क्या है? देयर कैन बी मोर देन वन ऑप्शंस दैट कैन बी करेक्ट. एक से ज्यादा ऑप्शन सही हो सकते हैं. ठीक है. अब आप देखो द क्वेश्चन, द फर्स्ट क्वेश्चन विच वी सॉल्व एंट्रोपी बेस्ड था. सेकंड क्वेश्चन विच वी सॉल्व इरिवर्सिबिलिटी की कैलकुलेशन थी मोर और लेस. सेकंड लॉ ऑफ थर्मोडायनामिक्स और इरिवर्सिबिलिटी पे बेस्ड है, एंट्रोपी बेस्ड क्वेश्चन है. थर्ड क्वेश्चन इज अ क्वेश्चन in which you see there is an expression given और ये बोला है वेपर प्रेशर इन mm of Hg, यानी ये जो प्रेशर है इसकी वैल्यू mm of Hg में आएगी जब हम सॉल्व करेंगे. ठीक है. इस इक्वेशन से ऑफ सॉलिड एमोनिया इज गिवन बाय, तो सॉलिड एमोनिया का mm of Hg में वेपर प्रेशर ये है, टेम्परेचर प्रेशर, एंड दैट ऑफ लिक्विड एमोनिया, लिक्विड एमोनिया का ये इक्वेशन है. ठीक. देन विच ऑफ द फॉलोइंग इज करेक्ट रिगार्डिंग टेम्परेचर एंड प्रेशर एट ट्रिपल पॉइंट. अब अगर हम ट्रिपल पॉइंट पे बात करते हैं, अब अगर आप देखो suppose let us solve this one. So when we talk about the triple point, so देखो, if we see this is the PT diagram, this is the pressure temperature diagram, ये PT diagram है और PT diagram is like this, कुछ इस तरीके से होता है for the general substance, है ना, PT diagram. So this is solid, this is liquid and this is vapor. So this is the triple point. तो ट्रिपल पॉइंट पे जो कैरेक्टरिस्टिक है, जो प्रेशर होगा और जो टेम्परेचर होगा, वेदर यू आर लिक्विड होके आप ट्रिपल पॉइंट पे हो, सॉलिड होके ट्रिपल पॉइंट पे हो और वेपर होके, इट शुड बी सेम. सो व्हेन वी आर टॉकिंग अबाउट द ट्रिपल पॉइंट प्रेशर एंड टेम्परेचर, दिस इक्वेशन एंड दिस इक्वेशन शुड गिव अस द सेम रिजल्ट, राइट? सो सपोज इफ दिस इज इक्वेशन 1 एंड दिस इज इक्वेशन 2, सो इफ वी इक्वेट द इक्वेशन 1 एंड इक्वेशन 2, अगर हम इक्वेशन 1 और इक्वेशन 2 को इक्वेट करें तो हमें मिलेगा दैट 23.03 माइनस 3754 अपॉन कैपिटल टी, दिस इज इक्वल्स टू 19.49 माइनस 3063 अपॉन कैपिटल टी. ठीक है. वी विल मल्टीप्लाई विद टी ऑन बोथ साइड, दोनों तरफ टी से मल्टीप्लाई कर देते हैं. तो 23.03 कैपिटल टी माइनस 3754 is equals to 19.49 t, 19.49 t minus 3063. अब इसको थोड़ा सा रीअरेंज करते हैं. 23.03 माइनस 19.49, तो ये 3.54 t आ जाएगा. 3.54, this is capital T, and 3754 this will go on the other side, minus 3063. So 691. So T will be equal to 691 divided by 3.54. So 195. It is 195.197 1977 Kelvin. इसको almost what we can do is 195.2 Kelvin we can say. थोड़ा सा राउंड ऑफ करें तो, है ना. अब आप देखो, वी हैव टू सेलेक्ट दी ट्रिपल पॉइंट टेम्परेचर. सो ट्रिपल पॉइंट टेम्परेचर अगर आप देखोगे, जैसे इसमें गलती हो सकती है कि 195.2 में अगर कोई 273 ऐड कर दे तो 468 मिलेगा. सो समबडी कैन चूज दिस ऑप्शन, बट ये सही नहीं है. सो दिस इज नॉट अ करेक्ट ऑप्शन बिकॉज इन दिस इक्वेशन ऑलरेडी वी हैव द टेम्परेचर इन केल्विन, सो वी शुड चूज बी. एंड व्हाट विल बी द प्रेशर? तो किसी भी इक्वेशन में आप रख दो, वेदर यू कीप इट इन इक्वेशन 1 और इक्वेशन 2, यू विल गेट द सेम रिजल्ट. We can say equation 1 implies, equation 1 में रख देते हैं lnp, log natural log of p is equals to 23.03 minus 3754 upon capital T, that is 195.2. तो यहां से p की वैल्यू आ जाएगी. सो 23.03 माइनस 3754 divided by 195.2 क्या आएगा? So log when go on the other side it will be e to the power something, so 44.63, it will be 44.63 और यहाँ से जो वैल्यू आएगी it will be in mm of Hg, mm of Hg. So 44.63 mm of Hg, this will be correct. 44.63, this will be wrong. So if we have to choose the correct answer, we will choose the ऑप्शन बी एंड ऑप्शन सी. प्लीज टेक दिस. Now let us move forward to the next problem. Next problem की तरफ आगे बढ़ते हैं. So now we have a question. There is a steam boiler. एक steam boiler की बात की गई, यानी this question you can see is related to the properties of pure substance type. तो question 3 हमने solve किया था, उसको आप कह सकते हो that question was from the thermodynamic relations topic, उससे related वो question था. So a steam boiler initially contains 5 meter cube of steam and 5 meter cube of water at 1 megapascal. मैं इसका एक रफ डायग्राम भी आपको बना के दिखाता हूं. I have not drawn the diagram already, क्योंकि क्वेश्चन सॉल्विंग में ये भी आपको थोड़ा सा पता लगे कि क्वेश्चन पढ़ने के साथ हम कैसे सिचुएशन को रिप्रेजेंट कर रहे हैं. तो देखो मैं बिफोर और आफ्टर का एक डायग्राम बना देता हूं. सो दिस इज लेट अस से बिफोर, राइट, पहले जो बात की गई है इस क्वेश्चन में. अब इस क्वेश्चन में ये एक पाइप भी है इसके साथ लगा हुआ. देयर इज अ पाइप कनेक्टेड हियर, देयर इज सम वॉल प्लेस्ड, राइट. नाउ व्हाट दे आर सेइंग, दे आर सेइंग steam boiler initially contains 5 meter cube of steam and 5 meter cube of water, यानी total volume 10 meter cube है, राइट. तो इसमें steam है और water है. तो we have water here, bottom पे तो water है, this is water, है ना, this is water. So this is water and we have steam also, हमारे पास steam भी है. So we have the upper portion is occupied, steam ने occupy कर रखा है. So this is 5 meter cube and this is also 5 meter cube, ये भी 5 meter cube है, 5 meter cube, ठीक है. And what is the pressure? 1 megapascal pressure है. This is situation 1, ये condition 1 है, ठीक है. This is situation 1 और प्रेशर कितना है? प्रेशर है 5 megapascal. This is the pressure. अब क्या किया जा रहा है? Dry stream is taken out at constant pressure. तो प्रेशर तो कांस्टेंट रहता है, ड्राई स्टीम बाहर निकालते हैं. ड्राई स्टीम का मतलब क्या है? With dryness fraction 1, मतलब there is no liquid that is going out, right? So कोई liquid बाहर नहीं जाएगा, the steam will go out and until 4 meter cube of water is left. अब इसमें water कितना बचता है? 4 meter cube water बचता है. So from here to we move forward, हम आगे बढ़ते हैं and we reach a stage this. एक दूसरी स्टेज में हम आते हैं and that stage is, वो जो स्टेज है उस स्टेज में this here we can show it like this, this is the stage. अब इस स्टेज में क्या है? we have water but 4 meter cube of water is left. जो पानी बचता है वो 4 meter cube है and we have obviously tank volume will remain constant, so we will have the water that will be 4 meter cube. water 4 meter cube होगा, तो मैं लिख देता हूँ इस बात को. so we have water left that is 4 meter cube, this is 4 meter cube and this is the steam which is obviously 6 meter cube, है ना. So we have taken out. Now what was being done? It was heated. ये heat किया जा रहा था. कैसे पता लगा? Because what they have asked is the heat transferred in the process is dash megajoule. तो जो heat transfer हुई इस पूरी process में वो कितनी होगी? How much it will be? So heat कितनी transfer होगी ये निकालने के लिए सबसे पहले आप देखो, we know initially कि there is some mass of liquid and some mass of vapor initially. Finally कुछ mass है liquid का, कुछ vapor का. तो some mass goes out. तो अगर कुछ mass बाहर गया तो what we will do is हम ये कहेंगे भी energy balance में, तो whatever energy was initially, जो भी energy पहले थी उसमें some energy entered, कुछ energy enter हुई है heat की form में और कुछ energy बाहर गई है ना. तो we should know what is the mass that has left, क्योंकि मास बाहर जाएगा अपने साथ एनर्जी लेके जाएगा. तो मास कितना आया है, मास कितना गया है. तो पहले कितना मास था, तो मास कितना था ये निकालने के लिए हम ये कहेंगे कि लेट मी डू द सॉल्यूशन हियर, ठीक है. तो हाउ मच इज द मास दैट हैज गॉन आउट. मैं कोशिश तो करूंगा सॉल्यूशन वैसे यहाँ आ जाए बट इट सीम्स टू बी डिफिकल्ट, तो लेट मी सॉल्व इट बिलो दिस. इसके नीचे ही सॉल्व करता हूँ मैं इसको, ठीक है. तो हाउ मच मास हैज लेफ्ट, सो मास m1 विल बी इक्वल टू, सो स्पेसिफिक वॉल्यूम क्या होता है, स्पेसिफिक वॉल्यूम, व्हाट इज द फॉर्मूला ऑफ स्पेसिफिक वॉल्यूम, सो स्पेसिफिक वॉल्यूम इज वॉल्यूम अपॉन मास, दैट मीन्स मास इज वॉल्यूम अपॉन स्पेसिफिक वॉल्यूम। सो अगर मुझे टोटल मास निकालना है इनिशियल कंडीशन में तो कैसे निकालूंगा, देखो Vf1 अपॉन V स्मॉल f कंडीशन 1 में, प्लस Vg यानी कि वेपर का वॉल्यूम और वेपर का स्पेसिफिक वॉल्यूम, ठीक है, ये होगा। अब ये हमें डेटा दिया हुआ है 1 मेगा पास्कल पे, तो अगर आप देखोगे तो इनिशियली मुझे किसका वॉल्यूम पता है, मुझे तो लिक्विड का वॉल्यूम पता है इनिशियली कितना है, 5 मीटर क्यूब है ना। स्पेसिफिक वॉल्यूम ऑफ द लिक्विड, स्पेसिफिक वॉल्यूम ऑफ द लिक्विड इज दिस 0.001127, सो 0.001127 प्लस वॉल्यूम ऑफ वेपर, सो दिस इज ऑल्सो 5, इनिशियली तो दोनों 5 है, एंड व्हाट इज द स्पेसिफिक वॉल्यूम ऑफ वेपर 0.1944, 0.1944 ये। तो वी कैन फाइंड आउट द मास इनिशियली हम मास निकाल सकते हैं, तो 5 डिवाइडेड बाई 0.001127 ये आएगा, प्लस 5 डिवाइडेड बाई 0.1944, तो ये 4462.278, तो 28 मान लेते हैं, 4462.28 किलोग्राम, ये इनिशियल मास था लिक्विड और वेपर के मिक्सचर का, यानी H2O का इनिशियल मास ये था, ठीक है। अब इफ दिस इज द इनिशियल मास, व्हाट विल बी द फाइनल मास, जो फाइनल मास है वो कितना होगा ये भी निकाल सकते हैं हम। तो फाइनल मास m2, द फाइनल मास, दिस इज द इनिशियल मास, एंड व्हाट विल बी द फाइनल मास, तो फाइनल मास जो m2 है इट विल बी इक्वल टू V2 Vf2, भाई जो लिक्विड का वॉल्यूम बचा वो तो 4 मीटर क्यूब है, तो मैं डायरेक्ट एक्सप्रेशन लिख रहा हूं, अपॉन स्पेसिफिक वॉल्यूम 0.001127 प्लस the volume of vapor is 6 and specific volume is 0.1944, क्योंकि प्रेशर वही है तो सेम प्रेशर पे सैचुरेटेड लिक्विड सैचुरेटेड वेपर प्रॉपर्टीज विल रिमेन सेम। सो वी हैव 4 डिवाइडेड बाई 0.001127 प्लस we have 6 divided by 0.1944, right? So we have 3580.1099 तो 0.11 किलोग्राम, दिस इज द मास विच इज फाइनली लेफ्ट, ये फाइनली मास बचा हुआ है, ये फाइनली मास बचा हुआ है इनसाइड द टैंक, ठीक है। सो दिस इज द मास विच गोज आउट, ये वो मास है जो बाहर गया, दिस इज द मास विच हैज गॉन आउट, ठीक है। अब ये जो मास बाहर गया आप देखो M2 3580 point sorry this is the mass which is left, so mass जो बाहर गया है the mass which went out, जो मास बाहर गया है वो कितना होगा, मास which goes out, मास जो बाहर गया है वो कितना है, this will be equal to m1 minus m2, so ये आ जाएगा 4462.28 minus 3580.11, so this is 882.17 kilogram, so this is the mass which has left out, ये जो मास बाहर गया है वो इतना है, ठीक है। अब आप देखो जो हीट जो एनर्जी आई और जो एनर्जी एंटर हुई हीट की फॉर्म में, दिस विल बी इक्वल टू वॉट एवर इज द एनर्जी चेंज, जो भी एनर्जी अंदर एनर्जी चेंज हुआ एंड द एनर्जी विच गोज आउट, ठीक है ना। तो एनर्जी चेंज क्या हुआ भाई, एनर्जी चेंज ये हुआ कि इंटरनल एनर्जी मान लेते हैं, स्टार्टिंग में एनर्जी कंजर्वेशन की बात करें, व्हाट वी आर टॉकिंग अबाउट इज द एनर्जी कंजर्वेशन, तो अगर इंटरनल एनर्जी U1 थी, है ना, इंटरनल एनर्जी U1 थी पहले, और बाद में कितनी बची, U2 बची, दिस इज द इंटरनल एनर्जी U2। चेंज क्यों आया, क्योंकि जो आने वाली एनर्जी थी, द एनर्जी विच इज एंटरिंग, आने वाली एनर्जी बढ़ाने की कोशिश करेगी, सो मान लेते हैं भाई हीट ऐड हुई Q, ठीक है, मैं हीट को क्या मान रहा हूँ, हीट एडिशन मान रहा हूँ ना, आई एम टेकिंग इट टू बी हीट एडिशन। और जो एनर्जी गई वो मास के साथ गई, तो मास एग्जिट, मास एग्जिट, ठीक है ना, तो दिस इज मास एग्जिट या मास आउट, मास आउट, दिस इज मास आउट इनटू द एंथैल्पी ऑफ द मास विच इज गोइंग आउट। तो जो भी एनर्जी चेंज आया वो आने वाली एनर्जी माइनस जाने वाली एनर्जी की वजह से आया, है ना। अगर जाने वाली एनर्जी ज्यादा थी तो जाने वाली एनर्जी को कम करेगी, आने वाली एनर्जी को बढ़ाएगी, ठीक है ना। तो अब आप देखो कि जो हीट है वो बाहर वो एंटर हुई है और जो मास है वो बाहर गया है और अपने साथ इट विल टेक सम एनर्जी आउट, ठीक है। दैट विल बी द रीजन फॉर द एनर्जी चेंज, यही वो रीजन होगा जो एनर्जी चेंज का रीजन है, ठीक है। अब देखो U1 जो एनर्जी है इट इज द, जस्ट अ सेकेंड, मैं इसको एक स्टैंडर्ड फॉर्म में लिख देता हूं जो हमारी अनस्टडी स्टेट की इक्वेशन है, कई लोग कंफ्यूज हो सकते हैं उससे। अनस्टडी स्टेट की इक्वेशन क्या है, U2 माइनस U1, ठीक है ना, U2 माइनस U1 इज इक्वल्स टू, अनस्टडी स्टेट का केस है ना। अच्छा, हाउ आई केम टू नो दैट दिस इज अ केस ऑफ अनस्टडी स्टेट। अनस्टडी स्टेट का केस है, ये ऐसे पता लगेगा कि इफ एनी प्रॉपर्टी चेंजेस विद टाइम, अगर कोई एक भी प्रॉपर्टी टाइम के साथ चेंज कर गई तो दिस इज अ केस ऑफ अनस्टडी स्टेट, अनस्टडी स्टेट का केस है, ठीक है ना। तो कैसे पता लगा, मास इज चेंजिंग विद टाइम, ठीक है। मैं मास अनस्टडी स्टेट की स्टैंडर्ड इक्वेशन लिख देता हूं, U2 माइनस U1 इक्वल टू MIHI, जो स्टैंडर्ड इक्वेशन होती है, प्लस Q माइनस MEHE माइनस WCV कंट्रोल वॉल्यूम पर। अच्छा, क्या कोई वर्क का इंटरेक्शन हुआ, नहीं। क्या कोई मास आया, नो, देयर इज नो मास इनलेट, सो देयर इज मास विच हैज एग्जिटेड, जो मास एग्जिट हुआ है ना, एंड दैट हैज कॉज्ड द इंटरनल एनर्जी चेंज U2 माइनस U1। याद रखो स्टैंडर्ड इक्वेशंस में, आई टोल्ड यू स्टैंडर्ड इक्वेशंस में हीट को आते हुए मानते हैं, ठीक है, एडिशन मानते हैं। तो अगर हीट एडिशन है तो इट इज ठीक है, फाइन। क्यू जो भी वैल्यू आएगी वो अगर पॉजिटिव आई तो इसका मतलब है हीट एडिशन हो रहा है, नेगेटिव आई तो इसका मतलब है हीट रिजेक्शन हो रहा है। तो M मास एग्जिट, दिस इज द मास एग्जिट इनटू एंथैल्पी एग्जिट, ठीक है। अब देखो, अब हाउ टू फाइंड आउट द फाइनल इंटरनल एनर्जी। फाइनल इंटरनल एनर्जी कैसे निकाले, फाइनल मास इनटू इंटरनल एनर्जी स्पेसिफिक टर्म्स में कैसे निकाल सकते हैं, स्पेसिफिक टर्म्स में भाई लिक्विड और वेपर का जो मिक्सचर है टू दिस एट 1 मेगा पास्कल, इस पे आप ये निकाल सकते हो कि व्हाट इज द स्पेसिफिक इंटरनल एनर्जी, पर यूनिट मास की इंटरनल एनर्जी क्या है, ठीक है। देखो, तो मैं एक एक करके निकाल लेता हूं। लेट मी कैलकुलेट द वैल्यू ऑफ U2 की वैल्यू निकालता हूं, U2। तो U2 कैसे निकलेगा, U2 विल बी इक्वल टू फाइनल जो इंटरनल एनर्जी है, इट विल बी इक्वल टू जो फाइनल हमारे पास लिक्विड का मास है इनटू, आप देखो इसमें हमें डेटा भी दिया हुआ है कि लिक्विड की इंटरनल एनर्जी क्या है और हमें ये भी डेटा दिया है कि वेपर की इंटरनल एनर्जी क्या है। तो मैं क्या लिख रहा हूं, फाइनल जो हमारे पास U2 है इट विल बी मास ऑफ लिक्विड 2 इंटू इंटरनल एनर्जी ऑफ लिक्विड प्लस द मास ऑफ वेपर mg इंटू इंटरनल एनर्जी ऑफ वेपर ug, ठीक है। तो mf इज व्हाट, mf इज द मास ऑफ द लिक्विड का मास है। तो लिक्विड का मास क्या है फाइनली हमारे पास, भाई हमें लिक्विड का वॉल्यूम पता है और स्पेसिफिक वॉल्यूम पता है, तो व्हाट वी कैन से द वॉल्यूम ऑफ द लिक्विड फाइनली इज 4, तो 4 अपॉन 0.001127 into specific internal energy of liquid 761.60 plus what is the mass of vapor, वेपर का मास कितना है, तो वॉल्यूम वेपर का तो 6 मीटर क्यूब है डिवाइडेड बाई 0.1944 है ना, इंटू इंटरनल एनर्जी ऑफ वेपर, इंटरनल एनर्जी वेपर की ये है 2503.6, ठीक है। तो दिस विल बी इक्वल टू, ये इंटरनल एनर्जी टोटल मिल जाएगी आपको, टोटल। तो टोटल इंटरनल एनर्जी निकालते हैं, 4 इंटू 761.60 डिवाइडेड बाई 0.001127, plus 6 into 2503.6 divided by 0.1944. तो जो टोटल इंटरनल एनर्जी है इट इज 2780, ठीक है, 0.377 into 10 to the power 3 किलो जूल. दिस इज द फाइनल इंटरनल एनर्जी. अब फाइनल इंटरनल एनर्जी ये है, तो व्हाट इज द इनिशियल इंटरनल एनर्जी? इनिशियल इंटरनल एनर्जी भी निकाल सकते हैं हम सेम मैनर में. वी कैन फाइंड आउट द इनिशियल इंटरनल एनर्जी. सो इनिशियल इंटरनल एनर्जी U1 इज इक्वल्स टू, आप देखो मास इट इज 5 अपॉन दिस, तो जो टोटल हमारे पास मास है दिस इज 5 अपॉन 0.00001127. this is the mass of liquid, yeah, into की वैल्यू हम लिख चुके हैं 761.6 प्लस 5 अपॉन 0.1944 into we have 2503.6 ये आएगा. तो टोटल इंटरनल एनर्जी इनिशियली भी हमें मिल जाएगी. So we can find 5 into 761.6 divided by 0.001127, this plus 5 into 2503.6 divided by 0.1944. So this is coming out to be 3443.275.27499 as I'm writing this into 10 to the power 3 kilojoule. So this is the, so there are a lot of calculations in this problem. So U1 seems to be not very difficult, but calculation काफी है. So U2 we know, U1 we know. Now U2 U1 पता है, Q पता करना है, ME मास एग्जिट निकाल लिया हमने, हाउ मच मास हैज गॉन आउट. HE, तो HE एंथैल्पी क्या है? एग्जिट मास की एंथैल्पी. तो द एग्जिट मास एंथैल्पी इज द मास हैज गॉन आउट. HG दिया हुआ है, देखो इसमें इस क्वेश्चन में ये दिया हुआ है, ठीक है. तो द मास विच इज गोइंग आउट इज द स्टीम जा रही है, तो HG इसलिए नोन है. तो नाउ वी कैन कीप द वैल्यूज हियर. देयरफॉर सपोज दिस इज इक्वेशन 1. इक्वेशन 1 implies, मान लेते हैं इक्वेशन 1 है, तो इक्वेशन 1 implies this U2 minus U1. so U2 कितना है? 27280.377 है ना. this is U2 minus 3443.275, but into 10 to the power 3 है for both of them, into 10 to the power 3 is equals to Q minus mass exit. How much is the mass exit? Mass exit is 882.17 into exit enthalpy is this 2778.1. तो Q निकाल सकते हैं हम. Let me do the calculation. 2780.377 minus 3443.275 into e to the power 3 plus we have 882.17 into 2778.1. so this Q comes out to be, this is coming out to be, just let me do the calculation once again. 2780.377 minus 3443 minus 3443.275. write this into e to the power 3. So plus, because this is minus, it will become plus 882.882 882.1717 into 2778.1. So this is coming out to be 1787.858 1787.858 into 10 to the power 3 kilojoule. Fine. So this is the answer, and here what we have to keep? We have to keep it in megajoule. So 1787, and they have not mentioned anything. 1787. So 0.8. So this will be 17. I'll just slightly round off. 1787.86 megajoule. This will be the answer. 1787.86. 1787.86. 1787.86 megajoule. This will be our answer. So please take this. I'll just show you on a single screen the entire solution. Yeah. Please take this. So now the next questions which we are going to discuss is the questions based on multiple choice question. So it is a linked data problem. So the problem 5-6 which we are going to solve is linked data problem. Let me go through the question first. So the question is, the interior lighting of refrigerators is usually provided by an incandescent lamps. That means the normal lamps which we use, not LED lamps, the normal bulbs which we used to use at home. घर पे bulb use करते हैं ना, येलो कलर की लाइट होती थी. Whose switches are actuated by the opening of the refrigerator door. यानी जब आप दरवाजा खोलते हो तो बेसिकली एक स्विच प्रेस्ड रहता है. वो स्विच अगर प्रेस है तो लाइट ऑफ रहती है. तो कई बार ये किया भी होगा लोगों ने कि जरा सा जब हम बंद करते हैं दरवाजा रेफ्रिजरेटर का तो देखने की कोशिश की होगी कि लाइट कब बंद हो रही है, लाइट बंद होती है कि नहीं बंद होती. तो लाइट बंद हो जाती है वंस यू क्लोज द डोर, बिकॉज द रिक्वायरमेंट ऑफ द लाइट इज नो लॉन्गर देयर वंस यू हैव क्लोज द डोर. सो whose switches are actuated by the opening of the refrigerator. So when you open, the light goes on. Consider a refrigerator whose 40 watt light bulb remains on about 60 hours per year. 60 hours वो टाइम है जब आप रेफ्रिजरेटर को ओपन रखते हैं, क्योंकि एक साल में तो नंबर ऑफ ईयर्स तो बहुत ज्यादा है, बट नंबर ऑफ आवर्स तो बहुत ज्यादा है, बट 60 hours are those hours when you keep it open the refrigerator per year. It is proposed to replace the bulb by an energy efficient bulb that consumes only 80 watt but costs 1500 to purchase and install. उसको परचेज करने में मैकेनिक को दोगे, वो आके इंस्टॉल करेगा, उसमें 1500 रुपीज लगेंगे. The refrigerator has to maintain -3 degree Celsius inside temperature, while average outside temperature can be considered as 30 degrees Celsius. And the actual COP is 20% of the ideal COP. Now, what we have to find out first, the electricity saved per year in kilowatt hour due to this change will be. So, how much electricity per year will be saved? This is the first part which we have to calculate. Then let us see the next question. If the cost of electricity is given, that is 8 per kilowatt hour, the number of years it will take to recover the cost of the replacement is approximately. कितने साल लग जाएंगे जो पैसा हमने लगाया उससे जो इलेक्ट्रिसिटी बचेगी उसको रिकवर करने में. ठीक है, तो let us start solving the problem. मैं आपको एक मूवमेंट दे देता हूँ, ये प्रॉब्लम दिखा देता हूँ, so that anybody who is solving or trying to attempt on their own can just go through the question and they can attempt, pause the video and attempt this question. ये MCQ problem, this is the problem. Next is the question number 5 and the question number 6. ठीक है, ये आपकी स्क्रीन पे डेटा आपके सामने है. You can pause the video and attempt this. ठीक है. Now I am going to solve this problem. मैं इस प्रॉब्लम को सॉल्व करने जा रहा हूँ. सो देखो, सबसे पहले वी हैव टू अंडरस्टैंड, हमें एक बात समझनी पड़ेगी, विच commonly people do mistake in these type of problems is कि electricity कैसे बचेगी, how the electricity will be saved. One part of the saving of the electricity is the direct cost which will be saved, because the electricity which you consume is given to the bulb also for 60 hours per year. So energy saved will have two parts. So the first part will be the energy saved due to the bulb directly. Energy saved due to bulb directly. How this will be equal to, so we are replacing it with a 18 watt bulb, so 40 watt minus 18 watt, this much watt less electricity will be required to light the bulb. Now this is in watt, so into 10 to the power minus 3, so this is in kilowatt. Fine. If we have to find out the electricity in kilowatt hours, so let us multiply with the number of hours into 60 hours. So this is the number of hours. So this much kilowatt hour electricity will be saved directly. So 40 minus 18 into 60 divided by 1000, it is 1.32. So this is 1.32 kilowatt hour of electricity is being saved directly, right? But this is not the only saving. Why? Because once you have used this bulb, see, where does the light go? The whatever light it will produce, whatever light the bulb will produce, that energy we will assume, that energy will be converted into the thermal energy, because whatever light, suppose किसी रूम में अगर आप बल्ब जलाते हैं तो वो जो बल्ब है, that whatever rays, radiation it is throwing, which makes you some things visible to you, क्योंकि visible range में fall करती है वो radiations, but radiations क्या है, heat ही है. तो once you have used this bulb, that bulb, whatever energy in the form of light it has emitted, that will get converted into heat, and your refrigerator will have to perform that work to remove that heat out of the refrigerator. तो मैं ये assume कर रहा हूँ कि जो भी, जब वो बल्ब लाइट होगा तो जो भी उसकी एनर्जी कंजम्पशन है वो हीट की फॉर्म में कन्वर्ट होकर रेफ्रिजरेटर में ऐड हो रही है, which the refrigerator will have to do effort to remove. So the B part is the energy saved due to less heat removal by refrigerator. So how much less heat removal will be required, ये देखते हैं. देखो, so if suppose we have this refrigerator, suppose we have this as our refrigerator, and in the refrigerator में it is removing heat, ये heat remove करेगा. तो कितनी heat remove करनी पड़ रही है because of this bulb, जो बच जाएगी. So we can say 1.32, इतनी इलेक्ट्रिसिटी कम लगेगी, तो दैट विल बी दी लेसर कन्वर्जन इनटू हीट, वही आपको कम हीट निकालनी पड़ेगी. सो हाउ मच लेस हीट यू विल हैव टू रिमूव, सो द हीट सेव्ड इट विल बी इक्वल टू 1.32 kilowatt hour, right? And from which temperature the heat is removed? So refrigerator operates at a temperature of, it is given to us, -3 degree Celsius पर refrigerator operate करता है, तो it is 270 Kelvin. It operates at 270 Kelvin. So how much electricity you will have to give lesser for this cause, कि इतनी एनर्जी बचेगी तो इतनी इलेक्ट्रिसिटी भी बचेगी, which you will have to give to remove this much energy, जो देनी पड़ती ज्यादा. So this W dot we have to calculate. This outside average temperature they have given it to be 30 degrees Celsius, so 273 plus 30 is 303 Kelvin. 303 Kelvin, right? Now the COP will be equal to this is 20%. जो actual COP है ना, actual COP, it is 20% of the ideal COP. Now how I came to know about this, they have given it in the problem. The actual COP is 20% of ideal COP. So how much is the ideal COP? It is TL upon TH minus TL. So what is TL? This 270 upon TH is this 303 minus this is 270. So we have the actual COP. So this is 270 divided by this is 303 minus 270 into 0.2. So we have 1.636. This is the COP. Let me just do a recheck of the calculation which I have done. Just let me quickly recheck the calculation which I have done. 0.2 into 270 divided by this 1.636. Yes. Now this is the COP, and how much electricity will be saved because of the lesser heat removal requirement. So we can say, but COP can also be written as, but COP is also be written as Q dot upon W dot, that is the desired effect upon the power supplied. So 1.636 is equals to Q dot is 1.32 upon this is W dot, which we have to find out. So W dot will be equal to 1.32 divided by this. So it is 0.80666 something. So 0.80, let us say 7 kilowatt hour of electricity that is saved. So how much total electricity is saved? It will be equal to part A and part B. So total saving, total electricity saved, the total electricity saved will be equal to A plus B. That will be equal to, how much is A part? That is 1.32 plus how much is B part? 0.807. So 1.32 plus 0.807. So it is 2.127 kilowatt hour. So 2.127 kilowatt hour is the total electricity that is saved, right? Now the total electricity that is saved is the question 5 that they have asked. So electricity saved per year. So obviously this is in per year terms. So we have the option D, 2.12. This is the option D which we have. So for question number 5, this D option is correct. So we have found the answer to question number 5. Now let us solve question number 6. If the cost of electricity is 8 per kilowatt hour, so how much electricity in terms of money is saved? So we are saving the value we have calculated. This is the cost. How many number of years it will take? So fine. So cost of electricity saved. So we can say cost of electricity that is saved will be equal to 2.127 into 8, because per kilowatt hour this is the cost. So 17.016, this much rupees per year. You have saved. Now how much extra money you need to spend to replace to purchase and replace this? It is 1500. So therefore number of years required. Number of years required to get our investment done, to recover initial investment will be equal to 1500 is the number of rupees which you have spent, and this is you are saving 17.016. So this will be equal to 1500 divided by the answer 88.15 be equal to 88.15 years. That means more than 88 years are required. So let us see which option it is there. C. So more than 88, that is almost, this is the best possible option. So more than 88 years are required. So are we going to consider this as our option that we have to replace this? No, obviously it does not make any financial sense to do this. So this is our answer. So answer is D and C. I'm just showing you the entire solution here, which I have done. You can take this. So I'll show you whatever I have written below this also. Yeah, please take this. So now the next questions which we are going to solve, question number 7 and 8, are also the linked data problems. So see here, we have a question here. Let us go through the question, and then I'll if somebody wants, I mean if you want to attempt yourself, I'll just show you the problem. You can pause the video and attempt, and then see the solution if it is required. So let me just show you it on the screen. This is linked data, this is the data, and the question number 7 with respect to this, and so you can note down or attempt it yourself. I'll also show you the question number 8. You can pause the video and you can attempt it. Now I'll discuss both these questions, question number 7 and question number 8. Fine. Here. Now see, let us go through this question and see how we can solve these two problems. So in the turbine of a gas turbine unit, the gases flow through the turbine and the power developed by the turbine is 14,000 kilowatt. So gases are flowing through the turbine and the power that is developed by the turbine is 14,000 kilowatt. The specific enthalpies of the gases at the inlet and outlet are, so enthalpy per unit mass for the gas at inlet is 1200 and at the exit is 360, right, respectively. And the velocities of the gases at inlet and outlet are 60 meter per second and 150 meter per second respectively. The rate at which heat is rejected from the turbine is 119.3 kilowatt. What we have to find out is the mass flow rate through the turbine in kilogram per second. So how much the mass will flow out of the turbine, and then the area of the inlet pipe, given that at inlet T equal to 1200 Kelvin, pressure is given. Take R for gases to be 0.125 kilojoule per kilogram. Fine. So per kilogram Kelvin, it should be per kilogram Kelvin. This should be the R. Fine. Now let us see the situation and try to solve the problem here. So we have the situation of a turbine. Turbine की situation है, तो turbine की situation में represent कर रहा हूँ. Turbine obviously I'll represent it with a diverging cross section. एक diverging cross section से represent करूँगा मैं turbine को. So this is the turbine here. ये turbine है और इसमें the inlet this is 1 and this is exit this is 2. ठीक है, और ये inlet condition is the enthalpy 1200 kilojoule per kg, exit is 360. So H1 is 1200 kilojoule per kg and this is H2 is 360 kilojoule per kg. Fine. Now the exit heat, the heat rejection is 119.3 kilowatt and the power developed is 14,000 kilowatt. We have to find out the mass flow rate. This is what we have to find out in the first part, right? So this is 14,000 given, Q dot is 119.3. So mass flow rate we have to find out, and we have also been given the velocities. Velocity भी हमें पता है, entry, inlet and outlet respectively. So 60 and 150. So we have C1 equal to 60 meter per second and we have C2 150 meter per second, right? Now if we write the conservation of energy, it is a steady flow case. So अगर मैं बात करूँ conservation of energy की, conservation of energy. So conservation of energy में what I can write? I can write that the rate of energy inlet will be equal to the rate of energy exit. Energy inlet का rate और energy exit का rate same होना चाहिए. तो inlet का rate कैसे निकालेंगे? भाई mass inlet is m dot per unit mass energy per unit mass enthalpy की फॉर्म में h1 और velocity के थ्रू c1 square upon 2. जब हम c1 स्क्वायर अपॉन 2 लिखते हैं ना, इफ वी राइट द वेलोसिटी इन मीटर पर सेकेंड, द यूनिट कम्स आउट टू बी इन जूल, यूनिट जूल में आएगी, एंड एंथैल्पी इज इन किलो जूल. तो सम ऑफ द बुक्स राइट हियर 2000, कुछ किताबों में यहाँ 2000 भी लिखा जाता है, ठीक है. तो ऑब्वियसली वी विल बी कीपिंग इट इन मीटर पर सेकेंड, हम मीटर पर सेकेंड में रख रहे होंगे. तो लेट मी राइट इट, या तो 10 to the power -3 से मल्टीप्लाई कर देते हैं या इसको 2000 कर देते हैं, ठीक है. This is the entry energy, right? And what is the exit energy? Exit energy is m dot into enthalpy exit H2 plus C2 square upon 2000. C2 square upon 2000. So again 2000 से क्यों divide किया? If I keep the velocity in meter per second, if I divide it with 2, unit will be joule. So मुझे किलो जूल में चाहिए because I will keep the enthalpy value in किलो जूल. This plus Q dot, देखो I simply know that energy is exiting in the form of heat. तो साइन कन्वेंशन का कोई रोल नहीं है, एग्जिट चीज को एग्जिट की तरफ ही रख दिया है, प्लस डब्ल्यू डॉट, ठीक है. सो एम डॉट की वैल्यू मुझे निकालनी है, तो आई कैन राइट एम डॉट h1 माइनस h2 प्लस c1 स्क्वायर माइनस c2 स्क्वायर अपॉन 2000 इज इक्वल्स टू q डॉट प्लस w डॉट, ठीक है. तो m डॉट इंटू, अब ये कितना है, h1 कितना है, h1 इज 1200, सो 1200 माइनस 360 प्लस व्हाट इज c1 स्क्वायर, सो c1 इज 60 होल स्क्वायर माइनस दिस इज 150 होल स्क्वायर अपॉन दिस इज 2000, दिस इज इक्वल्स टू व्हाट इज q डॉट, इट इज 119.3 प्लस व्हाट इज w डॉट, इट इज 14,000, ठीक. तो m डॉट व्हाट वी कैन कैलकुलेट फ्रॉम हियर, m डॉट इनटू, सो आएगा 1200 माइनस 360, इट इज 840 आ जाएगा, दिस इज 840, 12 डॉट, दिस इज 840 प्लस और माइनस ही आएगा इससे, सो 60 स्क्वायर माइनस 150 स्क्वायर डिवाइडेड बाय 2000, सो दिस इज माइनस 9.45, दिस इज इक्वल्स टू 119.3 प्लस 14,000. So we have 14119.3. So m dot will be equal to 14119.3 divided by, we have, this is 840 minus 9.45. So 16.999 something, यानी ये 17 किलोग्राम पर सेकेंड आ जाएगा. So mass flow rate की वैल्यू we have found out, it is coming out to be 17 kilogram per second. So 17 kilogram per second, that means we have the option A, that is correct, right? So first question we have solved out of this linked data problem, that is the question number 7, answer is 17, ठीक है. We are solving very good problems. आप अगर देखोगे the problems गेट स्टैंडर्ड के problems है, और ये problems ऐसे भी हैं जो बहुत relevant है हमारे एग्जामिनेशन के, थोड़ी न्यूनेस भी आपको मिलेगी प्रॉब्लम्स में. नाउ लेट मी टॉक अबाउट द नेक्स्ट प्रॉब्लम. तो नेक्स्ट क्वेश्चन में क्या है कि एरिया ऑफ द इनलेट पाइप निकाला. तो वंस वी नो द मास फ्लो रेट, एरिया हम लिख सकते हैं मास फ्लो रेट की वैल्यू से. सो लेट अस ट्राई टू राइट द एरिया मास फ्लो रेट के वैल्यू से. सो दिस विल बी क्वेश्चन नंबर 8 एक्चुअली. सो वी कैन से मास फ्लो रेट कैन बी रिटन एज A1 rho 1 C1, right? Now what is rho 1? So if we consider the gases to be ideal gases, which we can consider, gases को हम ideal gas कभी भी मान सकते हैं, we can take it. So PV equal to MRT. So we can say P is equals to mass upon volume will be density rho RT. So what will be rho 1? Rho 1 will be equal to P1 upon RT1. So we can keep this. Mass flow rate is 17 is equals to A1 into what is rho 1 is P1 upon RT1 into C1, ठीक है. अब इसमें जो वेलोसिटी मीटर पर सेकंड में ही we have to keep. So this is 17, this is 17. Let us see the unit of the area which they have given. The area of the inlet pipe given that this. So they have not mentioned anything. So I will suppose that the area of the inlet pipe, I will suppose that it is in meter square. Fine. So meter square में area है. This is what I suppose. लेट अस सॉल्व द क्वेश्चन, पता भी लग जाएगा. सो A1 आई हैव टू फाइंड आउट व्हाट इज P1. देखो A1 मीटर स्क्वायर में रखेंगे, ऑल दी स्टैंडर्ड यूनिट्स विच वी केयर. P1 व्हाट इज द प्रेशर, इट इज 300 किलो पास्कल अपॉन R इज 0.125. ये क्वेश्चन में गिवन डेटा है. आप देखो P1 गिवन है 300 किलो पास्कल एंड R इज 0.125. टेम्परेचर इज 1200. टेम्परेचर 1200 है. सो इंटू 1200, दिस इज इंटू 60. सो वी कैन फाइंड द वैल्यू ऑफ A1. A1 की वैल्यू आ जाएगी. सो 17 इंटू 0.125 इंटू 1200 divided by 300 divided by 60. So this is coming out to be 0.1416 meter square. ये आ रही है वैल्यू 0.1416. So 0.142 approximately, right? So this option C is the best possible answer. Option C जो है ये best possible answer है इसका, question number 8 का. So we have got A and C as the answers. Fine. So please take this solution. If somebody was not able to solve, आप देख सकते हो. I'll show you on the single screen. Please take this. So now we are going to solve the question number 9 and 10, right? These two questions are also the linked data problem, and they are of MCQ type. That means we have only one option as correct. So there is a diagram here and the attached question. So what I will do is, मैं question आपको दिखा देता हूँ पहले. If somebody wants to pause the video and attempt it. So this is the diagram, this is the data for this. So you can just take this, then I'll show you the question number 9 and 10 which is attached to this. So yes, this is the question number 9 and this is the question number 10 which is attached to this data, right? So if somebody wants to attempt it, you can pause the video and you can attempt it yourself. Fine. So now I'm going to solve this one. I'll solve this problem here. So what we have an arrangement here. Let us go through the question and parallelly try to understand this situation. So the arrangement shown contains 0.1 kilogram of air. So we have air inside this piston and the cylinder arrangement which is given. Initially the temperature is given and the pressure is given. The two sliding pistons are connected through a rigid rod. So this is a rod which is rigid. Rigid means it is not flexible. So whatever displacement the piston A will move, the piston 1 will move, the same displacement the piston 2 will have to move. Fine. In this diagram, this is A1 and A2. Actually, I have marked this A1 and A2. This is not the part of the problem because you can understand it yourself while reading the question. They have mentioned that the A1 area is less and A2 is more. So that you can see from here. So I have marked this as A1 and this as A2. So what we can see here is the two sliding pistons are connected through a rigid rod. The areas of the piston are A1 and A2, where A1 is given to be 0.01 meter square and A2 is 1.5 times of A1. So obviously A2 is more, so this I have marked as A2, right? Now a spring with spring constant K equal to 1 kilonewton per meter is attached to the piston with area A2. So this they have mentioned that this is the piston with area A2 on which the spring is attached, such that the spring is initially neither compressed nor elongated. So there is no compression or elongation in the spring initially, right? The air is heated till the pressure becomes 150 kilopascal. So the final pressure in this arrangement will be 150 kilopascal. Now what we have to find out is the displacement of the piston A1 and its direction is. So this is the A1. Now see, the direction of the displacement will be same for both the piston because this is a rigid rod which you have connected. So this rod is connecting these two pistons. So if A1 moves on the left side, A2 also has to move to the left side with the same displacement, right? So it is said the displacement of piston A1 and its direction is. Now let me assume something for solving the question and then finally we can see our assumption is correct or not. So what I am assuming is then when we will heat, so when we heat, the pressure of the air inside will increase, the pressure will increase, right? Now the pressure will increase. So what I am assuming is I'm assuming the piston will move towards the left slightly. Whether my assumption is correct or not, we can see it once we solve the problem. So, suppose the piston moves towards the left. So, as the A1 move towards the left, the A2 will also move towards the left, and they will move with the same displacement, right? So, this displacement suppose is x through which the movement happens. This is the displacement x, right? Now, if we have to find out the value of this displacement and obviously confirm whether it is on the left or towards the right. So, let me take the piston 1 and piston 2 and try to balance the forces acting on the piston finally, right. So, if I take the piston, let us say this piston, that is piston 2. So, I will say finally, I am doing the solution on this side. So, I will say finally for A2, for the piston A2, let me show the piston here. Finally, for the piston A2, so finally we have this color I have used. So, finally for the piston A2. So, this is the piston A2. Now, see what will happen when we are talking about the piston A2. We are talking about the piston A2. So, what forces will be acting on the piston? So, the spring is compressed finally if it moves towards the left. That is my assumption, right? So, my assumption is that the piston moves towards the left. So, there will be spring force because initially the spring is neither compressed nor elongated. So, there will be a spring force that is Kx, that is Kx. So, this Kx spring force will act on the piston towards the right side, right. Then there will be atmospheric pressure, and if you see here they have given the atmospheric pressure also 100 kilopascal. So, atmospheric pressure, and they have given us to assume the spring is linear, assume spring to be linear and P atmosphere is this. So, now the atmospheric pressure is also acting on this side. So, this is P naught into A2. So, this is the P naught into A2, this is the value P naught into A2, fine. This is the value for atmospheric pressure into area, this is the force. And what else the force will be there? Air is on this side. So, if the air pressure is finally 150, it will be applying some force on the piston. So, it will be P2. So, what is P2? P2 is the pressure which is final pressure. So, it will be the P2. So, the final pressure is let us say this is, I will represent it with dash because A1, A2 is for the pistons they have used. Na? So, I will use it, let us say P dash. So, P dash into A, this is P dash into this finally. And what else? See, this rod is there. So, this rod is there. So, in this rod there can be a tension in this rod, fine. So, there can be a tension in this rod, and I am assuming that the rod is whatever displacement is taking place. So, this displacement is basically such that the rod develops a tension. So, the tension in the rod is trying to basically, so it is trying to bring this piston on the inside and this piston also inside. So, this entire movement is trying to stretch the rod. So, the tension applied by this rod on this piston, I am assuming it to be inward. So, this is my assumption, right? This is my assumption that T tension will be there in the rod and this will be pulling the piston towards the right side, So, this will be a right side force that will act on the piston. There will be a right side force that will be acting on the piston. So, this is, let us say, T, fine. So, these are the forces which are acting on this piston. So, if I take these forces and try to balance these forces, because all the forces will be balanced, only then the equilibrium is possible. So, we can say all the forces which are which want to take the piston towards the right, they are kx. So we have kx plus p naught into a plus t is equals to p dash into a. So what is p dash? P dash is final pressure. This is the final pressure. This is the final pressure. This is the final pressure. Fine. So if I keep the values, so k is 1. So this is 1 into x. P naught is given to be 100 into area A. And what area A it is? It is A2. This is the area A2, right? Because we are talking about the piston 2, A2. So this is area A2. This is area A2. So A2. So what is A2? 1.5 times of A1, and A1 is this. So 1.5 into 0.01. 0.01. This is equals to P dash, the final pressure. So what is P dash final pressure? 150. So this is 150 into this 1.5, that is A2 is 1.5 into 0.01, this. So we have this x plus this is 100 into 1.5 into 0.01. So it is 1.5, and this is equals to, okay, so we have tension T also, which I have missed writing here. After this there should be the expression for T also here. So here we should have this expression of T. So plus this T is the tension here. So this T plus T. Now this question will give you some insight on your mechanics also. So 150 into 1.5 into 0.01, it is 2.25. 2.25. So we have x plus t is equals to 1. X plus t is equals to 2.25 minus 1.5. So it is 0.75. It is 0.75. So suppose this is equation 1, right? So we have got this as equation 1. Now we have got a relationship between x and t. Now let me make another equation with the help of the piston A1. So I can make another equation with the help of piston A1. So what we can write? We can write for the piston A1, for A1, for piston A1 finally. So for piston A1 finally, so we can show the piston A1 here. For the piston A1 finally, so what we have this situation, and for the A1 it has moved towards the left. So the tension which we are showing, this tension T will be there. Then there will be from the inside of the this cylinder, there will be force, that will be P dash into A1. This force will be there. So these forces will be there, P dash into A1. These force, so P dash is the final pressure into A1, and there will be atmospheric pressure acting on this side. It will be P naught. It will be P naught into A1. Fine. See, the final pressure is more. We can also say that why the rod will try to elongate and there will be tension in this direction, because if you see the piston A1, we also can explain this. If you see the piston A1, so if it has moved towards the left and the the pressure inside is higher than what it was before, so this force is more and this force is less. So obviously there will be some force which will be countering the excess pressure which has been developed. So there must be a tension in the rod like this. Fine. So we will balance it. So for balancing this, we can write P dash into A1, P dash into A1 will be equal to T plus P naught into A1. So just by observing the piston A1, we can make this statement, right? So we have P dash as 150. So this is 150 into A1 is 0.01 is equals to T we have to find out plus 100 into 0.01. So we can write 150 into 0.01 minus 100 into 0.01. So 0.5. So we have T is equals to 0.5. So value of T comes out to be 0.5, and obviously it will be in kilo Newton because we have the pressure in kilopascal, area in meter square. So this is this much kilo Newton, 0.5. Now, is this what we have to solve? No, we don't have to solve this. We have to solve the displacement. So we can keep this value here in equation 1. We can keep this value in equation 1. So we can say the equation 1 implies, we can say therefore equation 1 implies, therefore the equation 1 implies, so if we keep T as 0.5, so we get x equals to 0.25. It is coming out to be a positive value. Positive value means my assumption is correct. Whatever direction I have assumed, the direction is correct. Fine. So 0.25 towards left. So this is our answer, 0.25 towards the left. So option A for question number 9 is correct. So this is what we have to solve regarding the question number 9. So question number 9, our solution is complete now. I'll show you the entire solution once we go through the question number 10 also, right? So for question number 10, what they have asked is total heat supplied to air. So we have to find out total heat supplied to air in kilojoule will be. So for finding out the total heat supplied, we have to see the energy balance, right? So see here, it is a closed system. So I am solving the question number 10 here. Solution for question number 10 is here. So if you see for the gas that is present here in the piston cylinder arrangement, the gas is air. So for air we can say the first law of thermodynamics says Q is equals to delta U plus W. That means heat is added in the system. Sum of heat is used to increase the internal energy and the work is done by the system. So whatever will be the work done by the system, that we have to use. Fine. Now if the work is done on the system, we should keep it with a negative sign. So if I have to write this, I should write delta U. So delta U for the air, delta U will be equal to, this will be equal to m into Cv into dt, that is T2 minus T1. So our focus should be on finding out the temperatures. So initial temperature, I think, let me see, the mass is known to us, mass is 0.1, this is 0.1 kg mass. So initial temperature is known 300 Kelvin. So initial temperature is known. So what we can write here is, this is 0.1 into Cv 0.718, if they have not given anything, into T2 minus T1 is 300 Kelvin. So basically we have to find out T2. Let us say this is equation 2. So if we can find out T2, we can solve this. So how to find out T2? So we know the value of P2. Pressure at final condition is known. We know it is gas and the mass of the gas will remain constant, but if we are able to find out the volume finally, we will be able to, because P is known, the temperature we have to find out. So one more property we should know. So I am trying to find out the volume. So we can say that the change in volume for the air, will be equal to, now see how much volume of the air will change because of this displacement. So because of this displacement, some volume will reduce. It will be equal to area into displacement. A1 into x will reduce, but A2 into x will increase. So change in volume will be equal to plus A2 into x minus A1 into x. Now what is the change in volume? So change in volume is the final volume minus the initial volume, and this is equals to A2 is 1.5 into A1 is 0.01 into x is 0.25 minus what is A1, it is 0.01 into 0.25. Fine. And what is V1? So volume V1 also we will have to find out, because temperature is known, pressure is known, and mass is also known. So we can find out the volume V1. So this volume V1 also we have to find out. This is something we should calculate now. So let me first write at V2 minus V1, and then I will find out the volume V1. So V2 minus V1 will be equal to, so this is a wonderful problem. It is giving us a lot of insight into how to handle such type of situation. So it is V2 minus V1 is 1.5 into 0.01 into 0.25 minus 0.01 into 0.25. So 1.25 into 10 to the power minus 3 meter cube. Now what is V1? V1 we have to find out. So we can say, since PV is equals to MRT, so V1 will be equal to MRT1 upon P1. So what is this? M, mass is 0.1 they have given. Initially I think mass which they have given is 0.1 kg. So we have 0.1 kg of air. So 0.1 into R, for air 0.287, into temperature T1 is 300 Kelvin upon pressure P1 is 100 kilopascal. Let me just recheck here. 300 Kelvin, yeah, and 100 kilopascal, right. So we know the volume V1. So it is 0.1 into 0.287 into 300 divided by 100. So it is 0.0861. So V1 is 0.0861 meter cube. So we can find out the value of V2. Therefore V2 will be equal to this plus 1.25 e to the power minus 3. So 0.087 meter cube. So this is the value of volume V2. Why we are finding out the volume V2? We are finding out the volume V2 because we have to find out the temperature T2. Why we are finding out temperature T2? Because we have to find out the internal energy change. Why we are finding out the internal energy change? Because we have to find out the heat supply. It is a lengthy problem. It is a lengthy problem by gate standards. It is a lengthy problem, but still we will learn a lot while solving this. We will learn a lot through this problem. So now V1 is known, and V2 is known also. V2 is also known. So V2 is also known 0.08735. So we can find out T2. So how to find out T2? We can say P2 V2 is also equal to MRT2. So we can find out T2, therefore T2. So what is P2? P2 is 150 into 0.0. Volume is 0.08735. This, and divided by mass is 0.1 divided by 0.287. So 456.53. T2 is equals to 456.53 Kelvin. So the value of T2 456.53 Kelvin. Now if we see this T2 value, so we can find out the internal energy change. Therefore we can say equation 2 implies. So this is the equation 2 here which we have got. So equation 2 is 456.53 minus 300 into 0.718 into 0.1. So we have internal energy change delta U is equals to 11.2388. So 11.2388 it is. So I am writing 9, slight round of kilojoule. Fine. So this is the internal energy change. Now internal energy change value we have found out, but for finding out the heat supplied we should also know the work. So for finding out the work, see, if we have to find out the work W, so work done by the air. Now this is going to be interesting here. See how to find out the work done by the air. So when the pistons are moving, so there are two pistons on which the work is done. The air has this piston has moved on this side. So whatever is the work done by the air on this piston, where does that energy go? There has been some work done by the air on this piston. Now whatever work the air has done on this piston, that work is used to push the atmosphere. That work has been used to push the atmosphere out of its way, and also that work has stored some energy inside the spring, because spring has also got compressed, right? So basically the transaction of work between the air inside the piston cylinder arrangement and the outside is the atmospheric work involved and the energy stored in the spring, right? So the spring energy we can write by half kx square, that is the energy increment, because initially the spring was not compressed or elongated, and atmospheric work, because when this piston will move on this side, it will push the atmosphere, but atmosphere will help this piston moving on this side. So atmosphere is helping this piston. So work done by the gas on the atmosphere and work done by the atmosphere on the gas, both has to be included. So we can say the net work done by the gas should be equal to the energy which is stored in the spring, which is half kx square plus this is the net transaction with the outside. So spring energy, that will come from the air. Whatever heat you will give, some of it will be stored as internal energy, plus some will be spent as work. So whatever work has been done, some energy is stored in the spring, plus this work to push the atmosphere. So it is whatever energy goes to the atmosphere will go because of the pressure at the contact point of the piston and the atmosphere. It has nothing to do with the pressure here. The pressure here is pushing the piston, that's it. But that force which this pressure is exerting is also used to compress the spring plus push the piston. So P naught is the pressure at the contact of the piston and this surrounding. So P naught into A2. So P naught into A2, this is the force into displacement x. Now this is the work done on the atmosphere, but atmosphere has also done work on this side of the piston. So this P naught into A1 into x. So P naught, this should be minus, because it is the work done on the system, minus P naught into A1 into x. So if we write this, it is half of the k is 1 and x is 0.25 whole square, plus P naught is 100 into x is 1.5 into 0.01. This is A2, 1.5 into 0.01 into 0.25 and minus P naught is 100. P naught is 100 into, so this A1 is 1.5, sorry, A1 is 0.01 and what is x? It is 0.25. X is 0.25. So we can get the value of work from here. We can get the value of W. So value of work we can get. Let me just calculate the value of work from here. So we have 0.25 whole square divided by 2. This. So plus we have 100 into 1.5 into 0.01 into 0.25 plus actually minus 100 into 0.01 into 0.25. So 0.15625. So 0.15625 kilojoule. This is the work which I am getting. So now we have found out the heat I mean internal energy change, so we can find out the heat supply. Therefore we can say the heat supply will be equal to this plus the internal energy change, so plus 11.239, so it will be 11.39 something kilojoule. So this is the value of heat supplied, right? So if we see here, the best possible answer actually here, we have to round off up to the 2 decimal places, right? So if you see the values here, the closest option which will match, it will be 11.38. so this will be the answer, right? Now see, we have solved a significant number of problems, so you can see the solution and you can just go back in the video and you can just go through the problems which we have solved. So we have solved significant number of problems, and GATE 2024 के लिए I think this will prepare you for the GATE 2024, and also some new form of questions will give you a new perspective. एक नया perspective आपको मिला क्वेश्चन सॉल्विंग के लिए. जितना भी आपने सॉल्व किया, जो भी क्वेश्चंस आपने किए हैं अभी तक, जस्ट बी श्योर दैट वॉट एवर हैज टू कम आउट इन द एग्जाम, वो आपकी लर्निंग आपके सामने आ जाएगी. ऐसा हमें लगता है कि हम भूल जा रहे हैं बार बार, बहुत सारी चीज़ें ऐसी हमें लगती हैं कि हमने पढ़ी तो थी बट अभी याद नहीं है. बट अगर आप रिवाइज करते रहो अभी से एग्जाम तक जाते जाते, सो यू विल हैव योर वॉट एवर पोटेंशियल यू हैव. मैं ये नहीं कह रहा कि सबके मार्क्स 90 आ जाएंगे या 95 आ जाएंगे, बट वॉट एवर पोटेंशियल यू हैव यू विल बी एबल टू परफॉर्म अकॉर्डिंग टू दैट. जो डाउट्स आते हैं उनको आने दीजिए, बहुत बड़ा एग्जाम है, फियर भी होगा. सो या दिस इज फ्रॉम माई साइड. थैंक यू सो मच, एंड डू प्रैक्टिस इफ यू वर नॉट एबल टू सॉल्व दीज क्वेश्चंस. अगर आप ये क्वेश्चन नहीं कर पाए थे पहली बार में अटेम्प्ट में, तो फिर से दोबारा आप अटेम्प्ट करें, सॉल्यूशन देख लें, देन फ्रेश you should solve the questions yourself. Fine. Thank you so much. Goodbye. I'll leave it here and you can see the solution.